Okay, so let's see how we can use this package decision tree to do machine learning in Julia. So as we already learned that decision tree is a flow chart like structure, which is usually based on a tree-based learning algorithm. That is, like, it divides and then it uses the divide and conquer approach by using decision boundaries to partition or bisect the data so that we're able to predict and then pick and predict, right? Okay, so these are the packages that you need: decision tree package, and then DataFrame for our table manipulation, and then Gadfly for our plotting. So as we already learned, that is part of decision tree-based learning approach, and can be used for CAT, that is for classification and regression problems, right? So it also happens random forest as part of the package. The random forest is usually useful when you are dealing with huge sample data and you want to avoid overfitting. It's only useful when you are trying to solve a problem that decision tree will not be able to solve. Like, when you use decision tree, is very good, but it may produce overfitting. But when you are using random forest, it doesn't give you overfitting. Okay, so let's see. First of all, you need these packages, right? For this package, after that you load our data. So our data is taken from this website here, which is this main place. So you have several data that you can pick, but you'll be using this one to be picked from this breast cancer, and it's not labeled, so you try and label that. And then the other aspect too, this one also gives you the information about this data here, right? So it's giving you all the information, the groups, and then the attributes. So let's see how to do that. So we load it first of all. After loading, you see that it's not perfectly labeled, so we try and label it in this format using, the type of it is DataFrame, and then we try and label it. So this information here that we got, we use this names bank function to label it, and I copied this labeling from this place, right? On this place I copied it, and then I formatted it well, and I place it here as symbols to use it as our naming. So let's check and see. So when we checked it, it has labeled it perfectly for our sample code, clamp thickness perfectly. Nice. So that's one of the ways you can use to label your data frame if it's not labeled. So after that, let's try and see how to build our features. So we are going to convert our features, as we already learned previously that the features are usually these ones, right? So this is going to be our features, the ones that are required to help us predict. So from here to here, we're going to be dropping this. So we are going to call it S features. So we are going to convert them into an array, right? Because if you don't convert it to an array, it will be difficult for you to manipulate it. So we see that realize that this bare nuclei is inside a string, not a normal numbers or integers. So we'll try and convert it. There are several ways you can do that, but in this case we will try and remove that one feature and still work on it. So after removing that feature, I omitted that one, and then we move on to this. So this is our data. So we're going to try and use our label. So still the same thing, Y label. And then we are going to convert that class, which was severity, based on the severity, as our Y label. And then after that, we're going to use Gadfly to plot our data. So I'll load our Gadfly, and then I'll plot my data. It's very useful to plot your data to see what you're actually doing. So I'm plotting the features against the label using histogram. So it's going to plot it for us. So based on the classes, the severity, so these are the classes based on them, right? So now let's move on to the actual machine learning. So we can use, first of all, we are supposed to train our classifier. So we just use model and build tree, then contains the label, which is our features, our classes, and then our features, right? So it's going to build our decision tree with 14 leaves. The leaves are the number of decisions nodes that it's having, and then depth is 11. So the deeper it goes, the higher the tree. And then we are going to try and prune it. The reason why we prune it is to avoid overfitting. Overfitting is when some of the data overlap one another, right? For example, like trying to use something small to deal with something big, or trying to use something big to deal with something small. That is the purpose of that, is overfitting. So it's overfitting the data. So we are going to prune it, and then after pruning it, it's going to give us perfect still 11 because the data is not all that big. And then we try and print our tree. So there's a package called GraphViz, which can be used to make it more nicer, like an actual decision tree. So this is our print tree. So it's having these features, right? And then these are the leaves, left and then right. L for left, R for right. So the left is usually our yes, and then our right is our no. So to just build on based on all the features, and then it's going to build our tree for us perfectly. So after that, let's try and predict another tree using a random unknown data. And then our random data is going to tell us that this is our random data. It's going to tell us that it's having a security of 2, right? So based on our data that we had here, 2 was for benign and 4 was for malignant. So that means that the one that we actually picked here was a benign tumor. So we can even change it into something different. Let's make it fast. So let's see how accurate our model is. So we're using the cross validation accuracy, right? So the cross validation is usually used to estimate how accurate our prediction is going to be when we use our model and actual data. So you have two forms, either exhaustive, whereby it's going to divide the sample into training and then testing data, and then the non-exhaustive is going to divide it based on the k-fold. It's going to divide it into k equal samples. So let's try that one. So we'll be using the n-fold. The n-fold is the number of folds. So the number of folds we'll be using is 3, and then our purity is going to be 0.9, and it's going to be pruning this because of how the data is. So let's check and see how it's going to be. Okay, so based on our folds, which are 3 folds, we had an accuracy of 0.9 for our first fold, and then the kappa was 0.88. So kappa is usually used to estimate an agreement between right? So either chance agreement or complete agreement. So this one is 0.8. The next one was the accuracy was 0.95, and then the kappa was 90. So the higher the number, the more chance, the more higher it is in agreement, the more complete the agreement is, right? Okay, so the last one also give us 0.8 for the kappa and then 0.93, which is 93% accuracy for the third fold. So the mean accuracy was 0.94, that is 94%. So our model is quite good. We can use it on an unknown data. Okay, so let's try another aspect. This package also give us the option of using random forest, right, classifier. So you just go straight away with model is going to build forest. Instead of build trees, you'll be using build forest when you're using the random forest classifier. So we are going to be using the same labels, our Y labels and our S features of our same breast cancer data. Then it's going to be, I'm going to just choose 2 random features and then 10 trees. That is the depth of the trees I'm going to be using, because random forest is built on trees, and then this one is going to be optional. So let's move on. So when we check, we build our model, it's going to give us an ensemble of decision trees, which have 10 trees, and then average leaves is 37, which is quite plenty, and the depth is 10.9, just like 11, the previous decision tree classifier that we're using. So also we can apply that same model that which we have built on an unknown data, and then when we apply this, give us 2, whereby 2 means benign breast cancer, not malignant. Okay, so we can also use the same thing to check for accuracy of our model using n-fold underscore forest instead of tree. Then we're going to use it on our data, our label data, and our features, following the 3-fold and then number of trees. So it's going to give us these values, just like the previous one, an accuracy of 0.96 at 96% accurate, which is quite good. That means that random forest is having a very high accuracy rate, 95, and then the least one, the fourth, that is 96. So even the mean one is 95.8. That is quite good. So that is one example of one of the benefits of random forest classifier. Okay, so thank you for watching. If you have any questions, you can just put it inside the comment section. Stay blessed.